And thank you all for joining this event. Now today we have a speaker, Zhuowen. Zhuowen, how do I pronounce your name? Zhuowen?
Yeah, it's me.
Yeah, okay. And who is going to give us introduction speech about data analysis with and data graphics with R. And she's doing masters of information system in Melbourne, and she worked as a business analyst intern at ICONIZ. And so this presentation will give us fundamentals of R. And please join us. Join me in welcoming our speaker. And you can continue now, Tobey.
Yeah. Welcome.
Yeah, hi everyone. My name is Zhuowen Zhang. It's a Chinese name, so you can call me Tobey too. Yeah. So can I just switch off the video because I'm a little bit nervous to see my face. So yeah, okay, yeah, thank you. Okay, yeah. So today, we will introduce some basic knowledge about the data analyst and the graphs with the R. So here is our agenda. So the first part I will show you my opinion about why we need to do some diagram and which type is a good diagram. And the second part and the third part and fourth part, mainly we will do some practice in R. Okay, so yeah, first, so why we need to do some graphs? I think the first thing it will help you think about the data, right? And the second C is it will show more unexpected findings. And one more thing is it's a very useful tool to help you illustrate your finding to others. You just show your diagram or graph to the others. And the following, I will show you two examples about the bad graphs to show what is the elements of a good graph should be included. So you can see this diagram and maybe answer in the chat box about do you find any mistake or error or some disadvantages in about this diagram? Yeah. So how about your opinion? So any. So for this picture, so which part do you think there have some mistakes or disadvantages about this diagram? Yeah, so you can share your idea.
Maybe the gray font, the gray font is not necessary, and the horizontal line on the graph are kind of not necessary.
And where are the labels?
Yes. Yeah, this too is both, I think. Yeah. So, and I think the one more thing is about there is no title, right? So there's no title to illustrate what this diagram shows. I think this is a very, very important part. And actually there is one more thing is about the x-axis. It divides by 1 year, but the 1991 and 1992 is missing.
Yeah.
So yeah, here. So there is some mistake here. And one more, this diagram is very fancy, but yeah, still have some problem.
It's hard to see.
Yeah, it's hard to see. Even it's very fancy. Yeah.
Yeah.
And also I think the some of the elements is very, very, very hard to see, and also there is the 3 dimension and 3 axes here. So it's very hard to let the people know what's this meaning.
And also there is no title.
yeah, no title. And also there are, because there is a lot of things happen together, and some of the elements may be covered, overlooked by the other box. You can see like the Melb in the April. So we cannot see the box here, right? It's because it's just covered by the paper one and the green one. So yeah, even though it's a fancy one. So according to these two examples, I just want to share you with my idea about how a good diagram should be look like. I think the first thing should be like a single idea per diagram, and another thing is like the clear and meaningful lab, and the clear and informative title, and also avoid to using some fancy one. Just select the clear and appropriate diagram to do that. And then, so it's about the data we will use in our studio. It's some background, and there is several variables we will use later. And we can see the first variable is about diet. So it's the only one category variables in this data set, and the following others is all about the numeric variables. Yeah, so here is some background, and yeah, so let's do some practice in R. The first let's us just input our data set, and we first just consider about the one variables. So usually when we consider about one variables, like the numeric variables, we will consider about some basic descriptive statistics, like the mean, the standard deviation, the maximum number, and the minimum number, and median number, something like that. For example, when we consider about the average mark in the one subject, something like that. So there is some basic function we can use. The first one is the mean. So it's very easy. Just use the mean and enter the data what you want to do. So here we use the shape, right? And
it hasn't read that because you didn't set the working directory first, I think.
Oh,
okay. You just ran the second line, I think.
Oh, sorry. Oh, sorry. Yeah. Oh, sorry, I didn't. I just missed this. Come on, sorry. And
right.
yeah, and visualise, right?
Oh, it's just so. Is it? Oh, okay.
Yeah. So you can see the console. We can get the answer, right? So it's and when you consider about like the different categories, so like the mean in the different categories. Actually, we can use this function to do that. For example, here, we just mentioned before the diet. Here is a category variables. So we can use the calculate the length in the different category, and it's mean. So here. So we can see the result. It calculates the first category's average mean of the length and the second one. Yeah, so it's like a table to do that. And also it's the same for like the median. It's the same for the like median and like the standard deviation. It's the same, and also for the median and standard deviation, you can also use the apply this function. And what you need to do just modify the third argument to like the median or standard deviation. So you can achieve the same result. And there is one function that you can do this together, and it's called the summary. So in summary, I can show you the answer. For example, so when we use the summary, this function, it will list the 5 numbers. So the minimum and the quantile and the median and mean and the max, right? So also for the summary, you can also use the t-apply this function. And so here, actually the box plot is virtual display of the 5 number summary. So what that means is use the box plot, and we can add still the length here. So here we can get the 5 number summaries diagram, right? So the lowest part is the minimum, and the highest part, this line, is about the maximum number. But it is not a good diagram, right? According to our slides, it is not good because there is no title and no lab, and also usually we will put usually will put the box like the horizontal instead of this vertical, and so I think we need to add some elements or modify this diagram to make it be a good diagram. So first, just what I say, shape less, and I want to make it place horizontal. So just add argument about horizontal and add a t. T means true. So now it will be horizontal, and add the title, right? Title in R, the title usually use the argument about man. Sorry. So here is it's about the first is we need to illustrate which type of this diagram. It's a box plot, and the data of this diagram. So it's 30 shapes, February, less rows, and the time according to our background, and the location. It's a bit okay. So, and one more thing we need to do is add the lab, because now our box plot is horizontal. So this number will show in the x-axis. So what we need to do is to add the x-lab. So x-lab, and just enter the label you want to add. Like here is the February 10th, rows. Say okay. Okay, here is, and usually I will add one more argument. It's about LAS, this argument. Yeah, so here it is. So we can see now this diagram is better better than the previous one, right? It have title and also have the label, and there is a unit about this number, and also it's horizontal. And the final argument I add is actually about the direction of the X or Y lab. Usually the zero means it always parallel to the coordinate axis, and the one is means always horizontal. So if I change one here, it will show the same picture. It's the same. But if I change like the 2, it's a different direction. You can see the number. So I usually will use the 0 here. Yeah, I will more familiar with this style. Yeah, and one more thing is here we can use the histogram to present like the frequency in different ranges of the value of numeric variables. So what that means, I can just show an example. For the following diagram, always we need to add the main and the lab for X or Y axis. But I will do the sample version. But when you do the practice or in your real life, I think it's better to add this information in your diagram. So for the histogram, and also we use the lens. Yeah, yeah. So it's usually it will show the some distribution or like the frequency of the frequency in different ranges of the values of one numeric variables. And here is another plot related to the histogram, which is a density plot. So density plot is, I'll just show you the density plot. So the density plot is a smoothed histogram, right? It's very similar, but it's just like a smooth histogram. And why sometimes we will use the density plot? Because the subjectiveness of the histogram, for example, the choice of the bin with whites and the starting point is potentially unsatisfactory. So one strategy, we can just use this plot to try smooth them out using canal density estimators. For this one, we will not discuss in detail here, but if you're interested in it, you can just search in Google. Yeah. So here is about the one numeric variables and about one like the category variables. Usually we will focus on like the how many shapes in each diet, like the how many people in different age group, like something like that. So we usually use is the table to show the number of each category. Right. So here is the function. It's just mentioned in slides. The diet is a category variable. So we can see the answer here. Because according to the background, it's just divided into half. So for each category, they have the same shapes. And one more thing, it's about how to show it. And some people will just use the bar chart and the bar plot. Bar plot is a good way to show the category variables. And bar plot is, for example, about this one. There is some mistake because you will find the graph is not the one you want. So I can show you first. Yeah. So here, why the diagram is like that? Because it's just show the each shape in this diagram. But what you want is the how many shapes in each diagram. So what you want to show is like this table, right? In the diagram. So what we can do is that. So now we can get maybe this diagram seems a little bit funny here, but if there is a lot of diagram and each diagram have the different samples, it will be like the different lengths for each this bar. So and before we start to introduce like about the two variables, do you have any question about this or this part? Do you have any question about this part? So if there is no question, then we just enter into the second part about the two variables.
Yeah, Tobey, can you show the data set? Like
yeah, sure.
Rows and columns. That will be clear when we see the length.
Oh, okay. Yeah, sure. Sorry for that. I should this data set for you guys first. Okay. Sorry. Can I just show here?
Yeah, that's clear.
Okay. So yeah. So I just show you here. There have 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's variables. So like the first diet. So there is 2, and this one is this O is numeric variables, and this is initial weight and the final weight, and this is the oh, I forgot this one. Yeah, here. Okay, this is it's the rows and the length and its diameter and pericle and the yard. Yeah. Okay. Maybe you can do a screenshot. Screenshot. Yeah. Here is data set. Okay. So let's go to the second part about the two variables. So first, let's say the two numeric variables, for example. So we usually will use the plot this function. So it's for example here we use the yard. Maybe it's not meaningful. Yard and diameter. So and enter the data set. Which data set? Okay, and also here we need to add the the title and X lab, Y lab. Okay, I just enter the whole. Okay, actually the relationship, very simple, simple one, and x lab equal to February diameter. So, and the unit, and also the y, because now we have two variables. So like the Zhuowen, so always will add. Okay. Oh. Okay. Yep. So here is the graphs which can show the relationship between two variables, and usually the first argument first argument represents the y-axis, and the second one is the x-axis, and this is about which data is from. So there is another way we can show this one, especially when these two variables come from the different data set. So it's similar to the previous one variable. You can use the dataset name and the dollar sample and the yard and a wave, dollar yard, and the diagram. It's same here, but if there is a different dataset, you can do this way. Yeah. So so now here the plot, we use it to show the relationship between two variables. Actually, the plot can also use to show the one variables. Just take the above as example, we use the shapeless, and it's the default of the plot is use the dot to show the data. So here is, so it's we usually don't use the dot to show the data like this, right? So we usually use this histogram, and the plot can also do that. What they need just to modify the type. So type here is a histogram, so edge. So here we can get the diagram we want. And also there is another way to do with the line. Maybe it's not good here, but I just show you there is a way to do that. So if you just change the edge to L, it means for each point will be show like a line. So we'll do that. So usually we will show it by the histogram. So after we see this diagram, how to do like the quantitative the way to know the relationship between these two. And usually when we consider about the relationship between these two variables, the basic one is the linear relationship, right? So here actually we can use the cooperation relationship to do that. So here is the shape. Yeah. Shape yard and shape diameter. These two. So we can see in the console there is a result. which actually means there is a negative correlation relationship between these two variables. So next step, maybe we can fit this using the R linear model function. So in R, we can do it's first like the just build a model like the linear model one, and the LM function. So we just assign this to the linear model one, this variable we created. And LM means the linear model. So it's a linear model function in R. And the first argument is y, and the second one is the x. So here you can see we got the coefficient of this simple linear model here. Usually we will do one thing is about to see the p-value, right? So to see the p-value, is it significant or not? If it's significant, okay, you can use this coefficient. So you can use like the summary about this model. So here you can see these two coefficients and this coefficients and the intercept is both the significant, and maybe the coefficient intercept is not meaningful to see the p-value here, but still it's very significant. So it means that here we can do the basic linear regression or build the basic linear model here, right? So what we need to do, just add the built model, this line, to our graphs. So here is a function called apply. So apply, and so now we get this fighting line in our graphs. There is another way to do that, but compared with this function, that one will be less accuracy. Let me show you. It's used the curve function. So curve function is usually used to draw the diagram for the certain function. So here, because we have according to this part, we have got the function, the fitting function. So actually here, the curve can do is to put this 100. And multiple by x, this function. And there is a very important thing need to mention is this argument need to be added. It means this curve or this graphs or this line will be added into previous picture or previous diagram. It's true. So we can, okay, I just put and do that. So it's the same for this one, right? But compare with this the AB line, the curve one, because it uses the estimate number so it will be less accurate, I think. Yeah, so now just think about some like the distribution. So why we also need to think about distribution or show the distribution of the certain data set, because in Melbourne, the lecturer or tutor always told me that they will control the mark of the whole students. They will follow the normal distribution, the mark of the whole students in one subject. So I think it's a good way to just compare the data, your data distribution with the normal distribution to see whether it's flawed or not. So here what we need to do is first draw our data distribution. So it's a density. And the shape. We use another one. Okay, recall, and the same. We need to add like the title and next slide, something like that. Okay, so here is the distribution of our data set. So, but see this picture, we are not sure whether it is a normal distribution or not, right? So there's a simple way to do is to draw a normal distribution on the same page and to compare these two curves. So we use the same one, the curve function here, and this function, which means the density of the normal distribution. So as we all know, like the normal distribution will decided by two parameters. The first one is the mean, and then the second one is standard deviation. So here is the same. We should enter the mean, which is the same variable, and also the standard deviation. So that, don't forget, is true here, but it is not a good diagram, right? Because you can figure out which one is the normal distribution and which one is the distribution of your data. So you need to modify the curve to make it different from the original one. What we can do, we can change the color, right? We change the color, for example, the because I like blue, so I just use the blue here. So now it's a blue, but maybe it's still not very it's still hard to see.
Sorry, Tobey, a question.
Yeah.
So what was X?
Which one?
X.
X. Oh, X. Oh, X. Actually, here, this X is means the just like a sample, means the sample, just a sample. Yeah, it doesn't matter.
So did you define it previously?
Yeah.
And we missed that?
Sorry.
Did you define X variable and we missed that? Like I didn't get that.
Here it's like it's just like a default. It's like a default parameter.
Okay.
Yeah, it's more like, so it's very similar like what I mentioned before, like the curve one. This X is also don't make sense, but I just want to show this 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 linear model. I just want to show, told the R that what I want to show is a linear model. So I just use whatever the sample.
So if you had like second order, it would have been x to the power of 2, for example.
Sorry, x parameter 2.
I'm not sure.
Can you do question mark d norm? Like what is xx? Like what it has to be?
I think it's an input to curve function.
But what it has to be like?
Yeah.
How many values? How does it compute the normal distribution?
Yeah, so maybe we'll ask in the end. So you go ahead. Sorry for interruption.
Okay. No worries. Yeah. So yeah, it's a good question, but it's a good question. And usually, so if you have like the some question about this, you can use like when you enter, just what I showed before, when you enter this function. Oh, sorry. Okay, I just show you after this. Okay. So here, and it's still like a little bit hard to see the difference between these two lines, right? So what we can do is we can just modify the line of the normal distribution. We just modify the color. Also, we can change its white. So here is an argument about LWD. So we can change like the 2. If you change the number here, you can change the size of the line. So it will make this normal distribution more easy to different from the another one, and it still has some problem, right? Because if you see this diagram later, or if you just put this diagram or show this diagram to others, they will not know which line or which cover is about. It's about the normal distribution or which one is. So here you need to add the legend. So here is the legend function. Let me just to write the whole code first and explain it one by one. Okay, that's Melb. TITLE to distribution type. Let's see. And another one is the normal. And one thing is the and the color. See, black and blue. Yeah, that's awesome. So I can just show it for
Title spelling, I think. title spelling. I think you will have to.
Let me see on assign. Oh, sorry. Oh, yeah. Yeah. Oh. Okay. Okay. There is some typo here. Okay. So, yeah, you can see in the diagram here. So it will be more easy to show others or you see later. So the first argument you usually will put the position you want to place the legend, and the second one is about the related location. So like the accurate location about this legend. I can change it so you can know what that means. So if I change this one, So now here, so this legend just move from here to this place. And the third one is the argument, the CEX is about the size of the legend. So now I just set the 0.5. You can set like the 1, but it will be very big. It's very big. And the title is the title of the legend. And this one is about which how many category in this legend. So here there is a 2. The first is a periodical factor, and another one is a normal. So what I want to show is the distribution type. There is a 2, and this LTY, this argument is about the type of the line here. So the 1 means the some basic line. Just we see here. I can change to 2. The 2 is like the some dot line. So I can here. So you can see the periodical factor here have changed the type of the line, and the color is the same as above. It's black and blue. Okay.
Toby,
Yeah.
can I just say one thing? We have 8 minutes to go. Do
Okay.
you think that you could like finish in 3-4 minutes, and we would have 3-4 minutes for questions?
Oh, okay. Yeah. I try to do that.
That would be great. Tk you, because we want people have questions at least for like 3 minutes or so.
Okay. I just introduce one more method to do that. So it's a QQ plot. So QQ plot. So what's that QQ plot mean? Well, I can show the QQ the first. So it's we use this data, right, variable here. So the Q plot, it's another way to check whether this distribution is following the normal distribution or not. So the dots in the Q plot, if it's close to a straight line, it will be more close to the normal distribution. So here we need to add a line which presents the normal distribution. So here is a QQ line. Yeah, so here. So so we can see this this diagram, and according to this diagram, the Q plot, the dots in Q plots are very close to the straight line, right? And also for the previous one, the density plot is approximate like the shape of the normal distribution. So I think both of them illustrate the data. This data are likely to come from a normal distribution, right? So yeah, there is still have something, but there is no time. I think maybe I need to just stop here. Yeah, and for the following part, maybe we can share in GitHub.
Yeah, thank you, Tobey, for giving us an amazing presentation. It was like good, and we had some refreshing topics of all the graphics with R.
Yeah.
And any other questions from all participants?
Yeah, you can post in
GitHub. Yeah, if you can share me all the PPTs and remaining, I can share in GitHub, so people can view from there.
Yeah.
So about the questions, for the question, they can either unmute and ask the question, or if they don't want to ask directly, they can use the chat room to write down their questions. So everyone can see that. So whatever they prefer.
Yeah, both. Yeah, but I think it will be better to see in the chat box, because I can just see the chat box and do the practice directly in the R Studio.
participants, if you have any questions, please open your chat box and you can ask there.
Yeah.
Maybe give us a few minutes.
Yeah.
It's finally. Autocorrection.
Correction.
Thank you so much for the nice presentation.
I hope it will be useful for you guys. Is there any method to predict what distribution a data set is following? Is this normal or binomial or any other? Okay. Okay. So. Okay. So. Yeah, sorry, I don't know about this one. Yeah, sorry, because I still learning about this one. But I know the method, because usually what I do is I will see the data set first. So I will see data set first, and then I will do like to check the distribution. So your say is a normal distribution or the other distribution or not. I will see data set first and will decide it, like, because first, for example, some data set consists of the 0 and 1. So for this one, I think it will be not suitable for the normal distribution, right?
Yeah.
So I will choose the distribution of the dataset first, and then I will do the code in the R Studio.
Yeah, I see. So you mean that mostly visualization, looking at the distribution itself, would help to see what sort of distribution we have.
Yeah, because maybe there is some method to decide which distribution the dataset should use automatically, but I don't know it. And also usually I and with my like the tutor or my classmates, usually what we do, we will decide the distribution by ourselves first, and then do it.
Yeah, makes sense.
Yeah.
Thank you so much. It was really great presentation.
Oh, thank you. I just hope you enjoy, because I'm so nervous. So there is a lot of mistake.
You were great.
We couldn't tell you were nervous at all. It was really, really good.
Yeah, we are just so nervous. Yeah, thank you so much. Yeah.
Tobey, would it be also possible to share the code with us as well, so we would put all the materials available?
Yeah, sure. I can show you the code. And this code I have added some comments, so it will very clear for each part. I think it will be very useful if the person didn't come to this online workshop.
Yeah. So awesome. So because we share the data with people, then that's great to share the code as well. Okay, thank you so much.
Yeah, thank you.
Thank you, everyone.
Thank you.
I'm gonna end the meeting. Thank you, everyone. Have a good day.
Yeah, thank you.
Bye.
Thank you.
Bye.
Bye. See you.
See ya.
See you.